So the repository where we host all these training sessions related to the statistics module is here. And if you already downloaded the repository, that's totally fine. And if not, you can do so by clicking here, and you'd see what the Git access point is. And if you're familiar with this, I won't be able to go into very much detail now, but if you're familiar with this, you can Git clone that one. And afterwards, you go into the folder where the Git repository was downloaded to, and you run this command here, which is starting the notebook of the second session that we're having a look at. Oh yeah, thank you. There was Zio already posted the instructions in the chat, so you see that one there as well. If you opened it, that's fine, and you can do the commands just on your laptop or on your computer, on your own device as you wish. Otherwise, you can just look here, and we're going through the things interactively together. So what's today's sessions about? Last time we talked about the statistics module in PyPSA, which gives you an sort of a front-end layer for information, aggregated information about your model. So you have an optimization run, and then you want to inspect what's the actual capacity that was deployed, how do revenues and market prices and energy balances actually play out. And this is very handy, as you are able, if you remember, or perhaps you have tried it out by yourself, as you have quite some fine-grained control over what you want to aggregate over. So you can aggregate over carriers and bus carriers in PyPSA, or countries, and even introduce your own aggregation groups. And the output that we saw last time is tabular format. So you'd always receive a pandas data frame where you see these groups on the index or on the columns, and then the values in the array. That's very handy, and already gives you a lot of inspection power or inspection potential. But in order to make something more visible and visually appealing, there is another layer to this module, which is the plotting module. And this is what we're going to have a look at today. The session will take roughly 40 minutes. I'll try to be in time, perhaps even be a bit quicker, so there's enough time for questions. And the first cell I'm executing here, just have a look at the chat, but it seems to be fine by now. The first cell I'm executing here is this one where I'm just importing all the packages and loading a PyPSA network, which is already optimized. You'll find it in the examples under carbon management. So this should work out of the box. Yeah, it does. I'm happy. And now we have the PyPSA network and the statistics accessor loaded into memory. And statistics accessor you find under end.statistics. This is the same as we had before, but now we're going a little bit deeper into the functional layer. So why we want to use the accessor? This is just framing what we did last time as well. We have these these tabular forms that I talked about, and we can put them into plots. For example, if we call the energy balance function, that is a multi-indexed energy balance pandas data frame, and we can now process that and build a plot out of it with the pandas plotting function, which is also already very compact in a sense. And if we call that, we'd see, okay, now we have the carriers on the left-hand side and the values here on the x-axis, and with a bar plot, which already indicates quite a lot. So this is a two-line function call, which already produces a plot, which is very nice. But there is a more compact form with the statistics module, which is saying the same thing as before, but without typing the parentheses here. So we leave them out. And then instead running an accessor, which is called plot. So energy balance dot plot, and then another dot bar. And this gives you the access to this plotting functionality. If we call that, we see there's a similar type of plot that comes out. Now we have colors here, which are stored in the PyPSA network. And we see essentially the same thing, but with some more information. For example, we also have the unit here, the energy unit, the megawatt hours electric, which is derived from the PyPSA network. So this is, in a nutshell, what you would be able to do with the plotting accessor of the statistics module. And it's not only the bar plots and not only sort of these informational graphs that you see here. We will see later there's also maps that you can run and produce with the statistic accessor. There is some sound in the background, but I guess it's not a question. So I'll just continue. Important note is that there are two kinds of plotting backends, let's say. One is the one that we just saw, where you type n.energy balance or the other statistics function of interest with a dot plot afterwards. But there's another one which is called iplot, and it gives you essentially the same thing, but in interactive mode. We'll see that in a second. And I would recommend you to, if you have a Jupyter notebook, always use this one, because it just gives you more control and more interactive view. It already renders nicely into the Jupyter notebooks. So it does a lot of stuff and handy stuff for you. Whereas the plotting accessor, which produces static plots, it's called a Seaborn in the background. It's more for things that you want to perhaps save as PDF or PNGs, and then put that even perhaps to a report or internal sharing of information. So this is an important note here. iplot and plot, it's two kinds of backends leading sort of to the same outcome, but with different backends and also slightly different functionality. Secondary, there's a warning. If we think about our statistics module training session from the last time, we heavily relied on things like the group by and the group by time and aggregate across components arguments. These we don't use here in the plotting accessor. Why is that? Because the plotting accessor defines dimensions on the axis and potentially also on the facet grids that we'll see later. And this information already contains the grouping style that we actually need for our plots to be able to render correctly. So whenever we are plotting a time series, we're saying explicitly on the x-axis we have the snapshots, and on the y-axis we might have the carriers or the bus carriers. And this information already gives the backend the information how to group the data in the statistics module. So we don't have to care about how the grouping is actually derived and how we group by. This is automatically done by setting the information of the axis. Then again, we have plot versus iplot, two different backends. One is Seaborn, the other one is Plotly. And you see there's a slightly difference in what functionality is covered. So typical things that you want to plot is bar, line plot, and area plot. These are supported by both backends. Plot backend also extends this list by scatter, box, violin, histogram, and map plot. Where I have to say, these ones here in the middle, scatter until histogram, I actually never use them very much. There might be potential use cases which are handy. I didn't see them so far. We have implemented them in order to support the full palette, but at the moment, I couldn't come up with a good use case. Mostly, it's really about bar, line, and area, and then later, as we would see, also the map. As said, I'll mostly be using the iPlot accessor now. Let's see how this actually looks in contrast to the plotting. So here, firstly, I would run the capex plots with a static backend, so with the Seaborn backend. If we call that, we get a function which gives us the indicators that we passed here as arguments. So we said we want to have a look at the capex of the carrier solar, on wind, and off wind. So you get a bar view on these capital expenditures. There is a currency indicator here. It would probably be euros in most of the cases, or dollars, according to the unit that you're actually optimizing in. Now we keep it here generalized, because we don't have this information now in this network. And this already looks usable. We can change the aspect of the figure, which is how large the width of the figure is in relation to the height. So if we set a 3 here, we get a wider figure compared to the height. It is something very useful, because if we leave that out, things tend to get a bit squeezed. I think this is an aspect of 0.8, which is probably the default from Seaborn. I also like these more smaller or thinner plots. It's really a style question on what you prefer. Oops, no, this is not the one that I wanted. Two. Now, in contrast, we have a look at the iPlot bar, which is giving us the same thing. It's just firstly taking quite a bit, which is unexpected. But then, oh yeah, okay, I don't know. I just had to press another time. And now we see the contrast is obvious. When we hover over these different bars, we get information about the individual bars. This is a plotly feature, which is very nice, because you can also control more than just hovering over the individual objects that are plotted. You can, for example, filter out a list of carriers that you're interested in. So when you double click here, you'd see everything but the double-clicked item is filtered out. I can reset that by double-clicking again, but I also can unclick individual ones and therefore have full control of what is actually plotted. So it wouldn't be actually needed in terms of deriving different selections of carriers to set them here. You could also instead clicking them here on or off. Another information on why we see colors here and not in this manually created bar plot that we had on top. That is because PyPSA, in most of the cases, if you defined your network accordingly, has information about how to plot individual carriers. In the carriers data frame in the network, there is a column called color, and which sits side by side to the nice name color. And this stores information on how to plot things. So internally, we leverage this information in the statistics module and will reuse these columns defined here. If we have a more detailed look at the types of plots that we can run, I said there's bar plots, line plots, and area plots that we use most of the cases. We will go through them now, and we have a look at what other things you can control within these individual classes or categories of plots. So bar plot is one of the main things that you probably are interested in. It gives you nice aggregation layers. It's very sort of obvious what's happening. You directly get information. Here in this bar plot, I'm showing what the capex is. We already saw that, but now without a carrier selection. And again, you can individually select things here. You can also select things on a axis scale. So you can set individual upper and lower bounds for the axis and then see the area of interest. If we think about other filtering and control techniques, we can also think about what carriers are attached to the to individual bus carriers. You probably remember this from the last training session where we also leveraged the bus carrier parameter. If we call, for example, a filtering of the bus carrier AC, we get all the different carriers that are attached to the bus AC carrier. So all electricity producing devices and carriers you'd see aggregated here. This is mostly renewables that directly produce electricity, as well as electrolysis, which consumes here, but which also shows up, and other things that are directly attached to the AC sector in our network. You can also expand that view and include other carriers into this bus carrier list. Now, for example, we include the low voltage. And since we're not able to pack that into one combined plot, we're using a control mechanism which is called the facet column. So the facet column that will give you the ability to control how the ability to control that the bus carrier plots are going into individual subplots. So if we call that, you'd see now we have two different subplots, one for the low voltage sector and the other for the AC sector. They have a shared y-axis, so all the carriers show up here, and there might be individual ones that don't show up in the first subplot, but in the second one. You can also control that feature, but for the first run, I think it's obvious that you have this have a benefit of sharing the same figure with different subplots, because you get a direct feeling on how the different carriers relate to different sectors and how the quantities actually compare to each other. So, for example, we have vehicle to grid in the low voltage sector, quite some significant capacity, and on the other hand, we have quite some solar capacity in the AC sector. And there you can scan all the information and retrieve things that you're interested in. I find that very handy because you get the view directly and you see a visually sort of easy to digest thing on the different carriers. And if you think also about carriers that might occur in different sectors, so for example, CHP, we'll actually go into this in a bit, you'll see there's different capacities related to different sectors, right? So CHP is attached to the electricity sector, but also to the heating sector. So there's different capacities that you can allocate to different sectors. And this is something that you could also see here. Then you'd have other controls over things that you can filter out. For example, if you want to filter out the set of countries that you're interested in, as well as the different carriers, you can do so with a query string. That's another argument that is leveraged within the PyPSA statistics module. You'd see it's passed here as an argument. And I'm just saying I am now interested in the data that fulfills this condition. It is a query that you might know from the pandas package. It's something that filters data based on conditions of individual columns. So the country is expected to be column here, and now you filter with this condition. So the country column is expected to contain these individual values. This is passed to the bar plot function, and then sort of in the background used as the filtering mechanism. It is important, though, to note that all the different filtering techniques that you want to leverage in the query string, they sort of have to appear in your arguments that you use by the indicators of the plots. So you wouldn't be able to do that filtering on the countries if you hadn't specified the countries as one of these arguments here in either the colors, in the y-axis, the x-axis, or the facet row, or the facet column. Why is that so? Because we, as said in the beginning, these arguments here, they are used for producing the data that we're plotting. And the grouping mechanism is really based or derived from these. And if we don't have the country column or the country used in one of these arguments, the data that we use in the background, there wouldn't be contain the country column at all. So the filtering with a query wouldn't be valid. So it's important to know, if you're using the query, make sure things happen accordingly in the arguments here in the beginning. And what you get out of this one here is a figure that contains different subplots now scattered across the rows for the individual countries that we selected. So Germany, France, and Italy. And all of them, they produce bar plots with stacked capacity, supply for the individual carriers. So again, here on the x-axis, we have the bus carriers. Y-axis, we have the values. Colors are indicating the different carriers. They are stacked on top of each other. And then facet row gives us what the individual subplots in the rows are showing. And these are the countries. We can do some more fancy work if we leveraging the stacking mechanism. And for example, here I've said I want to have the capex for the individual countries now on the y-axis, but only for the bus carrier gas, so only for the gas sector. And now what the backend would do, it would see, okay, we are interested in bus carriers. Now let's select only the gas bus carrier and collect all the carriers that are actually attached to the bus sector, to the gas sector. And now let's group by the countries. And all these carriers, they are now stacked on top of each other because we passed here the stacked equals true argument. We can also do that without the stacking. And this is done here. And I attached a additional query because otherwise it would be bloating a little bit the notebook here, and only selected the countries that we looked at the top. So Italy, France, and Germany. And you get the same information, but now not stacked. So these individual parts of the bars, you would see they appear here in the same manner, but now they are scattered across, and you'd see what the individual things are here. We don't see the carrier y-axis labels here. We see them really as individual colors here, and you can select and deselect again here at the top right. There is one tip that you can use. You can always pass the query with a value bigger than 0, and then it will filter out non-zero values. It's something, I'm actually not very sure what the convention in PyPSA is, something that it should already happen. Sometimes it's handy to make sure that things are accordingly. So if you see a lot of sort of empty spaces, it's something that you can try out and do the query with a value bigger than 0. The second category, I just have to have a look at the time, but I think we're fine. The second category is the line plots. That's mostly used for time series, and it uses the same logic. So all these arguments with setting the x-axis, y-axis, and so this is always the same. It's just different kinds of plots that you're producing. And when you think about a line plot in PyPSA, it makes sense to have time series plotted as line plots, because this is normally what you would do. in the snapshots you have on the x-axis, and the individual lines then showing the values. And this is actually what's happening when you plot, for example, the energy balance plot. The x-axis always points to the snapshots dimension. So that would translate to an aggregate time false in the snapshot, in the statistics backend. And this is what you would get. So you'd see here, individual dates are displayed here, and the energy balance shows up for the individual carriers. Oh, by the way, I forgot to mention, I have pointed out what the equivalence for the static plots would be for all of these calls. So I would just now uncomment the second one and run the static version. Now the difference here is iPlot versus plot, and you get essentially the same plot. There's a bug that I saw. The carrier colors are not respected here, but it's in the pipeline. But when you go through the notebook, this is what I want to say. You can switch between the different backends by just commenting and uncommenting the lines. It gives you the same plots essentially, but with the two different versions of the backend. So line plots show snapshots on the x-axis. You can do the same filtering. Now we do here a bus carrier filtering with AC and low voltage as we had it before. We keep the x-axis as snapshots. And now do the facet row and the facet column on the line plots. And what we'd see here is sort of same thing, but with different subplots for the individual countries here on the rows and the individual sectors on the columns. And of course, you can always have a look at selections of your dates x-axis or on the y-axis with with your mouse and all the control that Plotly gives you there. And again, you can have a look at individual carriers by clicking over them here, double-clicking, whatever you want to do with that. So area plots is sort of the same thing, but now with a stacked form of display. It gives you a bit more this intuitive view, I'd say, where you have the total, in particular for the energy balance and supply and withdrawal, you always see what the total generation is for your network. And then you can do that for individual countries, and you see what the contributions of the carriers would be. And it's something that you see in most of the shared plots, also in reports, where line curves and so show up. So area plot is always stacked, and it's showing or it's summing up to the total energy balance at the edges. You can do the same thing with the facet row now and a bus carrier selection. So here we use a bus carrier selection H2 and AC, and we scatter these two across the rows with the facet row argument. And again, you'd see what is actually produced and withdrawn in the AC sector and what is produced and withdrawn in the H2, so in the hydrogen sector. What I find very handy here, when you have these cross-sectoral carriers, you can always select them and you'd see what they retrieve or what they withdraw from one of the sectors and what they produce in the other. So for example, electrolysis is consuming in the AC sector, but it's consuming electricity, but at the same time, it's producing hydrogen. And this is what you'd see here in this plot. And then of course you can do some double checking whether the ratio between input and output of the electrolysis is in place, and see whether the time series correlates. So you can also do some debugging here with this quite detailed control that that the plotting backend is giving you. Yeah, and energy balance gives you always a positive and a negative side of the plot. So it always should show if things are correctly set up in your network, should show what is produced and withdrawn at the same time in your sector. And these two, they sum up to 0. So the mean of the energy balance curves, if you take everything into account across the snapshots, they should always sum up to 0. It's just the energy conservation law that is behind that. When we think about more control over in these front-end functions, we already saw some of them. You can select bus carriers. You can also say what kinds of names you want to use. There is this nice names column in the carriers data frame. You don't have to use it. You don't have to specify it. PyPSA will fall back to some sort of default carriers name convention. But you can control all of these things. Again, you don't need the group by group time and aggregate across components arguments. These are derived from your default arguments and things that you pass. And things that you can pass, additionally, we saw that as well, is what you want to see on the x-axis, the y-axis, and see as colors. And all of the group by arguments that you know from the statistics model can be passed here. So it's really full control over what your grouping class is and how they appear in your plot. The same thing you can do with the facet col and facet row. There's this additional argument stacked, true versus not true. It doesn't always make sense to use it. It's mostly used for bar plots where you have one additional dimension that you sort of didn't include in one of the former arguments, and most of the times it's the carriers that are stacked on top of each other. So it's collecting sort of this additional degree of freedom. It's just stacking them on top of each other and then sort of collecting them in one bar. The query you can use for filtering, share X and share Y. We didn't use that now, but this gives you control whether you want to share the X-axis or the Y-axis of the subplots. So this is really for faceting for subplots and where you have shared axis or the potential shared axis. Then there is this sort of structural difference between the different backends, plot versus iplot. Plot is using Seaborn. It has different arguments for controlling additional things because of that. So here we have the height, the aspect, we saw that. D-spine for getting rid of the spines, of the frames, and so on. And subplot keyword arguments. All of these you can pass only with the plotting accessor, and they already give you quite some control. And it's handy to use them. I would recommend to do so in order to tweak your subplot as you would like to have it. And then in comparison, there's the iplot accessor, which uses different set of arguments. We explicitly didn't follow the route where we wanted to consolidate them and sort of branch off at a later point. We wanted to keep them separate. So iplot has different set of additional arguments. So it's again height, but it's in different units. So here it's in px, I think that's some pixels, yes. Then in absolute width, it's not an aspect. Title, facet role, facet call wrap, range X, range Y, and labels. So whenever you play around with these, I'd recommend to also play around with the keyword arguments. You have access to the objects that are produced from the functions by the return values. So for example, for the plots, for the static plot, which uses Seaborn, we get in return a figure, an axis, and a it's this I forgot the name. It's sort of an grid spec. I think it's a grid spec object from matplotlib. And these things you get, and then you can tweak them or you can do your control over these. So you can, for example, now say on the X object, you can set the title, which would then show up here. We said capex by carrier. It's showing up through this command here, and then we can also save the figure because we have access to the figure object. And then vice versa for the iPlot backend, we have things like the update layout and other control mechanisms that you can leverage with the Plotly library. So these are really then, as soon as you got the objects as a return value and you have them in memory, you can do whatever you want with them, and you don't rely on PyPSA internals now. You can do tweaks as you wish. Now for the last 5 minutes, I would quickly go over one additional class of plots that we have provided and implemented in the last 1.5 years, let's say, which is the map. And you might have seen other posts on the explore function in PyPSA. It's not the same. This one is really still using static maps and using statistics functions as sort of a front end, front and back end. So it's still in this accessor schema. And I'm just changing the default fixed size here to show you what's happening. And the API would be the same as we saw before. We would still have our S, statistics accessor, optimal capacity as a function that we want to sort of plot, then we have the plot accessor. And instead of saying bar, line, area, we're saying here map. But we have sort of the same arguments that we can use in order to do the selections. We have additional arguments that are really individual to the mappings. For example, here I said I don't want to draw the legend lines and don't want to draw the branches. It's detailed information now. It's not super important. But what you get back is a map of all your buses with the geographical layers in the background and these typical PyPSA plots, as you might know them, with shared circle plots for the individual carriers and buses. You can overlay them here. For example, I've plotted the same thing with the optimal capacities and with transmission capacities on top. It's a bit crowded, but it also gives you quite some information where things are expanded, where you see DC lines versus AC lines. The things you can also plot here is, for example, the hydrogen sectors. You can do, since you can control the bus carriers, you can also control what sectors you're plotting, and it's what we're doing here. So here you see hydrogen pipelines and hydrogen production facilities or installations, all of that. Same thing counts for the CapEx, where you see what the capital expenditures allocated to different regions and assets would be. And here it's a bit weird currency. It would be euros in most of the cases for our studies here in Europe. But this is really up to individual use cases. And energy balance, that's a sort of opinionated plot where we see a split circle on the buses, where we have the top half circle indicating what energy was produced, and in the lowest half circle shows you what energy was consumed. So here we'd see, okay, here in where's that, Sweden, we'd have quite some wind production and some significant solar production, and and on the other hand, hydrogen or electrolysis, electricity consumption. Again, you can do that for AC and hydrogen for all the sectors that you're interested in, and you see these energy flow and energy balance plots right out of the box. Here, for example, we're showing the hydrogen sector again. Okay, for the sake of time, I'd speed up a little bit. There is other arguments, as I said, that you can that you can use here: transmission flow, setting to 0, control over the legends, and other things like not having a look at the production capacities, but on the storage capacities. This is what we do here, for example. This is really it should be terawatt hours. I'm just recognizing its storage capacity, and have more fine control over things like the legend. So at a glance, the map is an individual accessor that does not share too many arguments with the other accessor points like the bar, line, and area, because we are in this geographical realm where we rely more on sort of this mapping logic. And therefore, you'd really need to find your way when you use these plots and these backends, and always have in mind what the individual purposes of the functions are. So recap: bar, line, area. This is the main access points that I would recommend at this point. They all support plot and iplot backends. And then we have on top, we have for the plotting static backend, the map that we can use. They all have these filter arguments with the carriers, bus carriers, and queries. We for the for the bar until area plot, we can control things with X, Y, and color, and facet call and facet row. And these sort of replace the group by controls in the statistics module. We don't use group by and group time and aggregate across components. For the iplot, we only have bar until bar, line, area, but that's fine. And for now, we don't have the map. And yeah, for sector coupled networks, that's something I would always recommend. Use the bus carrier. You always use the bus carrier argument. So you're making sure you're really focusing on one sector and you're not mixing them up. Of course, there can be cases where you want to group different sectors, like heating sectors. We have urban and rural heating sectors. You can group them together. But as soon as you mix units, you actually wouldn't want to do that. You have control over, more fine-grained control over your objects by using the return values. It's figure access in facet grid, that's the object for the static case, and figure and access for the map. And plotly only returns figure. And color tweaking you can do by setting colors in n.carriers as well as the nice names. You have access to the plotting documents. Here's a link. I'm not entirely sure what the current state of this section is, but it should at least give you a partial overview of what we just did here. Probably this is also extended in future. Okay, now I would close my focus training session and come to questions and discussions if you have any points that you want to raise.
Thank you, Fabian. I hope everybody had time to look in the chat where there is a link and a code to Slido where you can ask questions. And then we're just gonna, in a second, put up the questions on the screen so we can go through them together. All right. So, Fabian, there's a question here. Is it possible to change the order of the carriers in the stacked area plots?
That's a good question. Perhaps we can go back to the stacked area plots. Here, I would need to try that out. If we pass the carrier explicitly here, what do we have? Gas, and let's do gas CHP. I am not entirely sure whether this, if we now change that. Did it change? I think it changed, right? So first comes gas, then gets CHP, and now, oh no, it doesn't change. It doesn't change. So it seems that this is not taking into account the order that we have here. It's probably because of some set operation that we do in the background. But it's a thing that I can put down to my internal list. When I produced this notebook, I actually also had some things that I wanted to follow up on. So at the moment, it doesn't seem to be supported.
Thank you. Let's see. There's another question on how can we change what is displayed in hover mode? Hover mode.
Oh yeah, you can do that. It's quite in the depths of Plotly. I'm not entirely sure what the access points would be. There is control over that. So whenever you, for example, let's go and get the figure here, and you see this is now the Plotly figure, and it has all these update functions. Is it update? I think I had it here below. I didn't use Plotly too much, to be honest, as a sort of plotting library. There is quite fine-grained control that over these figures. So, for example, hover. Oh, now I messed up. Does it allow me to look at again what we had here? No. Sometimes it shows up and sometimes not. I guess there is these updates traces thing. I think it's called update traces, and there you can also do some hover control, but you'd have to look it up. But I'm pretty sure it works with Plotly controls here.
And I believe there was then a question about documentation for functions, mapping functions.
Sorry, say again.
Where can we find information on how to use the map functions? Is there documentation available for them?
I think at the moment the documentation on them is quite limited. I'd have to look it up again. So as said, we might want to extend the documentation on the user guide here. I think most of them, they only show how to do the plots themselves. Here we go. Here's the plots. You have some documentation on the argument, but I don't think you have too many examples here. So if you can scan this, and it's quite a large list of arguments that you can access, but it doesn't give you too many examples, or it doesn't give you actually any examples. So it had to be some hybrid thing approach that you now want to do. So use the notebook, see what's happening there, and then also go into the stocks that I linked.
And there's one question here about the location of the title. Is it possible in iPlot to change the location of the title to to the center in the middle?
It's definitely possible. It's definitely possible. I just don't know how at the moment. It's here, for example, we have perhaps there's a positions argument. Let's try center. I don't know if that works. So you'd have to play around with these. It seemed that my kernel crashed. Let's try restarting it. And I think all cells above selected. Yeah, let's do that. Oops. So if I scroll down again, we should come to this here, center. No, it does. It's not center, but I'm sure there is quite some control over how to do the title, how to plot the title. You'd have to look it up in the Plotly library documentation, though.
Right. And then there's a couple of more questions here. Once again, on the hover function, can I plot time series data that lets me hover over the date range and carrier type?
Yes, this is what we did. So, for example, here, we're plotting the energy balance with an area plot. And here you can hover all over these contributions. You'd see what is the contribution of solar, run-of-river, reservoir, and all of them that produce now electricity at this snapshot. So you see here on the bottom, there we have a selection of all. You see what snapshot is currently selected or is hovered over, and you get that detailed information. I have to say, though, it's sometimes a bit confusing with these energy balance plots to get the right selection of the bottom half, because what we're doing here is we're plotting once the Plotly chart for the positive side and once for the negative side. So it might that for the energy balance plot, we actually lose the hover information on the lower side, so on the negative side. For all the line plots, you get them directly. Perhaps I can, if I select just this range, no, it doesn't show it. It's a pity. It's probably also something I want to put on the list. But it's something that is there. For all the line plots, they would be accurately shown. For the energy balance plots and the area plots, the negative side is a bit off because you don't see them in the hover information. Did that answer the question? Okay. Oh, sorry, Charlotte, you're muted. We don't hear you.
Thank you. Let's take two more questions before we're closing down. Is there a way we can contribute to the plots generated by PyPSA using dot plot, the plot function?
Yes, there is the dot plot function, which is at the moment outdated. Oh, it's now I did something bad. Okay, whatever. Here, the dot plot function is deprecated at this moment at this stage. So you probably know this n dot plot thing. I even don't know if it's it's showing something. It's something that we wanted to deprecate because we wanted to make things a bit more fine. Oh, it's not deprecated in this version. What do we have here? Let me have a look. Dot plot, explore, iplot map. Yeah. Okay. Yeah. So what's happening here is these statistics plots, they are they live in an individual or in separated module and don't share a lot of code with the plotting function. That said, the mapping accessor in the statistics plotting function or module, they are actually using the map function here. So the map function that we get from the n.plot.map or n.plot, they have all these controls over how to size the buses, how to filter the branches and all that stuff. And this is something that we leverage quite vastly in the map access of the statistic module. But yeah, contributing, I'd say something like the interactive map, if we could, that would probably be a next step, interactive map that could be incorporated into the statistics module. That would be very nice. So in order to do s.energybalance.iplot.map, that would be something very cool. And it would probably leverage the explore function in the background.
Thank you, Fabian. One last question. Are the countries labels included in PyPSA, or do you have to specify them afterwards?
Yes, you have to specify them. And there is country column in the buses data frame. And this is where you want to specify them. And as soon as you have, you can use them. And then also the underlying components that would be aggregated to the buses accordingly. But if you didn't, then this country assignment, it would just fail, or in most of the cases, it would just collect to an empty string, which would then give you the total aggregation. So it's always wise to specify your network and give the network as much information on the aggregation groups as possible.
Good. Thank you very much, Fabian. Thanks to everybody here, everybody who asked questions.